So we have some more motion problems. Sometimes these are a little tricky, so we'll see what we have. And we'll show you more, again, how to use the chart. So Christopher and his parents live 115 miles apart. Okay, so Christopher, his parents, we know the distance is 115 miles between where they live. They meet at a restaurant between their homes. So we don't know where the restaurant is. Somewhere, though, there's a restaurant. It's an IHOP, to celebrate his mother's birthday. Christopher drove 1.5 hours while his parents drove 1 hour to get to the restaurant. Okay, so let's make our chart. So it's nice they're meeting for his mom's birthday. And we know that we have Christopher driving, and then we have his parents driving. I didn't draw cars. And we know that rate times time equals distance. Okay. Now the total distance is 115 miles. Okay, so keep that in mind. Okay, Christopher drove 1.5 hours. Now I'm going to go ahead and use a decimal, so 1.5 hours that Christopher's driving. And the parents drove 1 hour, so 1 hour for the parents driving. Christopher's average speed was 10 miles an hour faster than his parents' average speed. So let's call the parents' average speed X, and then Christopher's going 10 miles an hour faster. Okay, so that's the rates and the times. And then if you multiply, then the question, what were the average speeds of Christopher and his parents as they drove to the restaurant? So we're trying to figure out what X is. But here's how you can use the chart. Remember, it's rate times time equals distance. So the rate, x plus 10, times 1.5, that is how far Christopher's driving. And then the parents, it's 1 times x. I'll put x times 1. That's how far the parents are driving. And then we go back to what we said earlier, together. So the distance that Christopher drives plus the distance his parents drive, that has to equal the 115. So Christopher's rate times his time, that's how far he drives. X plus 10 times 1.5. And then the parents, they're just driving 1 times x. And that equals 115, a total of 115. So the parents, maybe they're driving 60 miles an hour. The parents are going to drive 60 miles, okay? All right, so there's the equation. I'm going to go ahead and distribute here. So 1.5x plus 15, right? Power of 10, so plus 1x. Now, we could clear the decimal and multiply by 10, or we can just live with the decimal. That's kind of up to you. I'm just going to live with it. It's not too bad here. So I've got 1.5x and 1x. That's going to be 2.5x plus 15 equals 115. So I've got to finish solving this. Oops, no problem. Subtract the 15. So now I have 2.5x equals 100. Now I wish I would have multiplied that to get rid of the decimal. Okay, so x equals, what's 100 divided by 2.5? 100 divided by 2.5. 40. The parents are driving 40 miles per hour. Hopefully they're not on the freeway. Okay, so parents, they're driving 40 miles per hour. And then Christopher, he's going 10 miles an hour faster, so he's going 50 miles per hour. There we go. All right, so we have another one. Pierre and Monique leave their home in Portland at the same time. So Portland, wherever Portland is, and Pierre's going and Monique's going. P for Pierre and M for Monique. Pierre drives, oh, no, not like that. Drew it wrong. They're not going in the same direction. Okay, so Pierre drives, you should read the whole problem first. Pierre drives north on the turnpike. Okay, so he's going north, and he's going 75 miles per hour. And Monique, she's driving south at 68 miles per hour. How long will it take them to be 429 miles apart? Okay, so again, you want Pierre's distance. This is Monique. Pierre's distance plus Monique's distance. That's what's going to equal the 429. Okay, so we'll take our little chart, set it up. Usually in these charts, there's two people or two trains or two things going on. We've got Pierre. And we've got Monique. Okay, their rates, we know their rates. Monique's going 68 miles an hour and Pierre's going 75 miles an hour. What we don't know is the time, but we know they left at the same time, so they're traveling for the same amount of time. I'll just use T for time, and T for time, and the distance. Well, the distance that Pierre goes, 75 times T, because it's rate times time equals distance, and the distance Monique goes is 68 times T. And then together, the 75T, so how far Pierre goes plus how far Monique goes, those are their distances. That's what has to equal 429. Okay, so what's 75 plus 68? 143. And I'm sure I should be able to figure this out in my head, but... Okay, so 3 hours. Oh, I didn't show my work. 143, I'm dividing by 143. And it turns out that the time is 3 hours. So the question is, how long will it take them to be 429 miles apart? It will take 3 hours. Okay.